All right, so the next shape we're going to talk about is called a trapezoid. So this again is a quadrilateral as well because it has 4 sides. But what's special about a trapezoid is that it has exactly one set of opposite parallel sides. Now these opposite parallel sides are not congruent, they're just parallel. Then the other 2 sides in a trapezoid that are not parallel are called the legs. So we have just a trapezoid in general, which you'll see in here and here as well. Now, we also have a special kind of trapezoid that we name it when the legs are congruent, and that's called an isosceles trapezoid. So with an isosceles trapezoid, we have 3 different characteristics that we're going to focus in on. First is that the legs are congruent. So if the legs are congruent, remember the legs are the non-parallel sides, we're going to set them equal to each other to solve for the values. So in this case, I'd have 3x minus 2 equals x plus 8. All right, and then we're going to just go through the algebra here. Subtract x from both sides. So that leaves me with 2x minus 2 equals 8. I'm going to add 2 to both sides. So I have 2x equals 10. Divide both sides by 2. I get x equals 5. All right, so again, if it's an isosceles trapezoid, the legs are congruent, and we're going to set them equal to each other. Next, we're going to talk about what we call the base angles. So again, in an isosceles trapezoid, base angles are angles that are on the same base. So the parallel sides, we call those bases. So on this base, TW, these 2 angles here are congruent to each other. And then on this base, UV, these 2 angles are congruent to each other. All right, they are not all congruent all together, but it's only the angles that are on that base. So those 2 are congruent to each other. So if I'm asked to solve, I'm going to set these equal to each other. So I have 9x minus 1 is our first angle, and that's equal to 80. So I'm going to add 1 to both sides. So I have 9x equals 81. Divide by 9. X equals 9. All right, so again, base angles are congruent. So the angles on the same base are congruent to each other. All right, and then lastly, we have that the diagonals are congruent. Now, the diagonals are the lines that come from one corner to another corner. So it looks like a diagonal line, so across the inside of the shape. So EG is a diagonal and FD is a diagonal. So since those are in an isosceles trapezoid, we know that those diagonals are congruent. So to solve, we're going to set them equal to each other. So EG is 6, so 6 is equal to DF, which is x plus 1. So to get the x by itself, I'm going to subtract 1 from both sides, and I get x equals 5. All right, so now we're going to practice these properties again. So I see that I'm talking about angles in this first trapezoid. It's isosceles because the legs are congruent, all right? They have those same markings on each of those legs. And so what I know about these base angles is these are congruent to each other. So I have 32x minus 8 is equal to 120. So I'm going to add 8 to both sides. So I have 32 equals 128. And then, 32x. And then I'm going to divide by 32 on both sides. And I'm going to get x equals 4. All right, so again, those base angles are congruent to each other. In this next trapezoid, we have our diagonals are congruent. So AC, this diagonal, is congruent to BD, this diagonal. So since they're congruent, we're going to set them equal to each other. So I have 17 equals 5x plus 2. So again, my goal is to get that x by itself, so I'm going to subtract 2 from both sides. So I have 15 on the left equals 5x. Going to divide by 5. X equals 3. All right, and lastly, again, this only works on isosceles trapezoids, and that's when these legs are congruent to each other. And since those legs are congruent to each other, we're going to set them equal to each other. So I have 8x plus 5 equals 4x minus 15. All right, I'm going to subtract my 4x from both sides. So I have 4x plus 5 equals negative 15. Watch those signs. I'm going to subtract 5 from both sides. So I have 4x equals negative 20. Divide both sides by 4. I get x equals negative 5. All right, and that's how we would work with these properties in isosceles trapezoids.